Welcome back. Today we're going to begin talking about how absolute value functions shift, kind of like the examples you were seeing yesterday. So let's view the general idea and then let's check out some examples. So here, the general idea basically relies on knowing what your parent function is. So your parent function is the absolute value of x, and this portrays this classic V-shaped pattern right here. And as long as you know that this V-shaped pattern is centered here at the origin, then if you add or subtract things, you can just move around this picture to the left, to the right, or vertically up and down. So let me show you what I mean. Here it says, given the graph, describe the transformation of f of x equals the absolute value of x. So remember, this is the classic V-shape graph that was centered at the origin. So let me go ahead and draw a little table that represents these 5 points. So I created a list of the 5 points. So negative 2, 2 is this point right here, negative 2, 2. Negative 1 is this point, negative 1, 1, 0, 0, 1, 1, and 2, 2. So I'm going to go ahead and graph these 5 points. And I'm going to do it onto this graph here so I can see what's going on. So negative 2, positive 2 is right there. And I'm going to do it in yellow here. Negative 1, 1 is right here, 0, 0 is right there, 1, 1, and then 2, 2. So here's f of x equals absolute value of x. And now we want to see what this green function is. So let's go ahead and count how many units it went up vertically. Let's begin with this point right here. Actually, let's do it an easy point. Let's start at the origin. So we can see we go 1, 2, 3, 4. So we went plus 4. And you can see that this happens from every point. So here, if we go up 4, you're going to see 1, 2, 3, and 4. I know it's not to scale, but you can see that 2 plus 4 gave you 6. And then right here, you can do the same thing. 1, 2, 3, 4. So we're going up by 4. So this green function is f of x equals the absolute value of x plus 4. Let's go ahead and try another example, such as this one. So let's graph the classic f of x equals the absolute value of x graph first. So we can see that these are the 5 points of the original graph. And now we gotta see how many units it goes down. So let's begin with the origin, and here we can see it goes down 1, 2, 3. So we're subtracting 3 units from each point. And if we look at this one, for example, you can see that if we subtract 3 units, we're gonna go 1, 2, and 3. We land here at this point. The same thing here. 1, 2, and 3. So the green function here is going to be f of x equals the absolute value of x minus 3. And here's the general rule for vertical movements. So for vertical shifts, the general idea, basically, this is how we write the functions. Okay, if we want to shift upwards by a units, we're going to add by a. And if we want to shift the graph downwards by a units, we're going to subtract by a. So here you see that we subtracted this by 3 because we wanted to move it down. And here we added this by 4 because we wanted to move it up. Alright, horizontal shifts are going to have a similar flavor. So let's go ahead and take a look at those ones, beginning with this example. So let's begin by graphing f of x equals absolute value of x. So to graph this function, we're going to plot the origin. We got to plot negative 1, 1, negative 2, 2, 1, 1, and then 2, 2. So this is the yellow function, which is the absolute value of x. And now we want to move it to the right. So let's see how many units it shifts. And let's do that by analyzing the origin right here. So we see that it moves to the right 1, 2, 3 units. So moves right 3 units. Now the interesting thing here is that you may think that we're going to have to add by 3, but in reality we have to subtract by 3. And here's how we do it. We're going to write the green function as f of x equals the absolute value of x minus 3. Alright, so if we're moving to the right, we're actually subtracting inside the parentheses. So that's what happens for horizontal shifts. We're looking inside the parentheses. For vertical shifts, we were looking outside of the parentheses. So again, for horizontal shifts, we tend to do the opposite. So if we move to the right, we're going to subtract. If we move to the left, we're going to add. And you can prove this by just plugging in points. So for example, if you plug in 0, 0 minus 3 is negative 3, but then the absolute value of negative 3 would land you at this positive 3. So here we're going to avoid those technicalities because we just want to shift the graph. That's all we're interested in right now. So let's go ahead and check out another problem, such as this one. So like the rest of the other problems, let's graph the f of x equals absolute value of x function. So here we plotted our first point at the origin, then 1, 1, negative 1, 1, negative 2, 2, and then 2, 2. And we have our little sketch here. And now let's analyze the origin and see how many units it moved to the left. So here it moved to the left 1, 2 units. Okay, so again, beginning at the origin, we move 1, 2 units to the left. 2 units left. So if we move to the left, we know that we're going to have to add. So here we're going to have f of x equals the absolute value of x plus 2. And for horizontal shifts, again, if we're moving left and right, we write the shift inside the absolute values. So here's the general rule for these. For horizontal shifts, f of x equals the absolute value of x plus a. We shift the graph to the left by a units. And if we subtract by a, we shift the graph to the right by a units. So check out the problems, try them out, and then when we come back, we'll see a different variation of shifting problems.